Welcome. Today, the global market for jams and preserves is valued at nearly $5 billion. France is the world's leading consumer, with an annual consumption close to 1 million tons. Jam is the sweet companion of choice for many people around the world, but how is jam actually made? To find out, let's travel to Scotland and visit a processing plant. Jam first appeared as a way to preserve fruit before refrigeration existed. Ancient civilizations such as the Egyptians and Romans cooked fruit with honey to extend its shelf life. With the arrival of sugar during the Middle Ages, the Arabs perfected the technique and introduced it to Europe. In the 18th century, the Industrial Revolution expanded production, and in the 19th century, the development of airtight containers made jam more accessible. Companies like Kyler and Sons in Scotland helped establish commercial jam production. In the 20th century, advances in the food industry allowed for greater variety and quality. Today, both artisanal and industrial versions are produced, including sugar-free, organic, and innovative ingredient options. Even though the processes have evolved, the essence remains the same, a combination of fruit and sugar that allows the flavor to be enjoyed for longer. Jam continues to be a traditional food in many cultures, appreciated both at breakfast and in cooking recipes. So, what is the process? The manufacturing process begins with a fundamental stage fruit selection. The quality of the final product depends heavily on the raw material used, so it is crucial to choose fruit at its optimal ripeness, free from major defects. In the case of strawberry jam, for example, the berries are harvested from fields dedicated exclusively to this purpose, ensuring they meet the required standards of freshness and flavor before. Cleaning and preparing ingredients is, well, a critical step. Processing the fruit goes through a thorough inspection to discard any that show signs of fermentation, mold, skin damage, or other imperfections that could affect the final product's quality. Once harvested, the fruit must be transported quickly to the processing plants. This step is critical because from the moment fruit is removed from the plant, it begins to undergo natural processes such as respiration, transpiration, and accelerated ripening. Additionally, if any mechanical damage occurred during harvesting or transport, the fruit becomes more vulnerable to microbial growth and premature spoilage. To avoid a loss of quality, the time between harvest and processing must be kept to a minimum. Upon arrival at the processing plant, the first step is to weigh the fruit and temporarily store it in proper containers. It then goes through a rigorous cleaning process using potable water to remove any traces of soil, dust, pesticide residues, or other impurities. This washing is done with pressurized water or by immersion in tanks, depending on the type of fruit. After cleaning, a second visual inspection is carried out to ensure that only the best pieces move forward in the production line. The next step is peeling, which varies depending on the fruit type and quality. Some fruits are peeled mechanically using machines with rotating blades, while others require chemical methods such as immersion in hot water or sodium hydroxide solutions, which help loosen the skin without damaging the pulp. Once peeled, the fruit goes into a comb mill, a specialized piece of equipment that helps classify the fruit by texture and size before moving on to the next stage of production. Inside the production plant, the fruits that have passed the selection, washing, and peeling stages move on to the next phase, turning into puree. On a conveyor belt, they enter a mechanical cutting system that breaks them down into small pieces, ensuring a consistent texture while preserving the natural feel of the fruit. However, not all of the raw material follows the same path right away. To achieve a balanced texture in the final jam, only 70% of the fruit is processed into puree, while the remaining 30% is kept whole. This allows the final product to retain small fruit chunks, giving consumers a more natural experience. Once the desired size is reached, the resulting pulp moves to an automated weighing station. Here, high-precision sensors determine the exact amount of raw material, which is It's essential for calculating the correct proportion of sugar to be added in later stages of the process. Next, the mixture enters the cooking section in large industrial kettles, and the fruit is gradually heated under controlled fire. This step is crucial because it breaks the cell membranes and releases the natural pectin, the compound responsible for the jam's characteristic texture. Depending on the fruit's juiciness and moisture content, water may need to be added to prevent the mixture from sticking to the bottom and burning. The amount of water added depends on the fruit type, the volume being produced, and the intensity of the heat source. As the temperature rises and the mixture begins to boil, it is kept at a low simmer until the desired consistency is reached. In cases where water has been added, the cooking process is extended until the original volume is reduced by about 1/3 before sugar is added. This phase is one of the most delicate parts of the manufacturing process. Both temperature and cooking time must be carefully monitored, since any variation could affect the quality of the final product. Overcooking may lead to caramelization of the natural sugars, darkening the jam and altering its flavor. For this reason, experienced operators with technical knowledge closely monitor the system indicators to ensure that the fruit's color and aroma remain intact. To optimize the process, cooking can be done in two ways: at atmospheric pressure in open kettles or under vacuum in sealed vessels, depending on the production method used. Afterward, the mixture is transferred to a continuous cooker, where the temperature is precisely regulated until the ideal consistency is achieved. In the next stage, the pulp is refined through a screening turbine. This filtering system removes any leftover skins or unwanted particles, ensuring a smooth texture. The refined mixture is then pumped into a mixing tank with a double jacket heated by steam. In this controlled environment, the essential ingredients that complete the jam formula are added: sugar, ascorbic acid, citric acid, and pectin, all in exact proportions. These additives not only enhance the texture and flavor of the final product, but also extend its shelf life, ensuring optimal preservation. Once the mixture has reached a smooth and uniform texture, it is pumped into the batch vacuum concentrator, where it is thickened until it reaches the desired Brix level. This parameter, measured with a refractometer using a sampling device, indicates the concentration of soluble solids, mainly sugars, and must reach a minimum of 65 degrees Brix to ensure the proper level of sweetness. In addition to sugar content, the consistency of the jam is essential. It must be viscous and spreadable, making it ideal for pairing with bread, cookies, desserts, and pastries. Before the jam is ready for packaging, quality tests are performed to verify that it has reached the optimal point. One common method is the water test, where a drop of jam is placed into a glass of water. If the drop Distribution and storage are honestly critical steps in ensuring the jam reaches consumers in perfect condition. If the jam sinks to the bottom without breaking apart, the cooking is considered correct. Another method is the cold plate test. A small amount of jam is placed on a chilled plate, and when tilted, the product should stay firm without running. These tests, ensure that both texture and consistency are suitable before moving on to the next stage. Once the ideal cooking point is reached, the jam is removed from the heat and the surface foam is skimmed off to create a cleaner, more uniform product. It is then transferred to a new container to prevent overcooking, which could affect its color and lead to unwanted crystallization. Next comes the packaging process. Glass jars, starting at 250 grams in capacity, are washed and disinfected using steam and filtered air to ensure sterility. After that, an automated filling machine dispenses the exact amount of jam into each jar as they move along a conveyor belt. The jars are immediately sealed with safety caps, ensuring the product is fully protected from any external contamination. After sealing, the jars pass through a cleaning system to remove any residue on the outside before labeling. Then, the product is rapidly cooled, which is a crucial step for preserving quality and promoting vacuum formation inside the jar. As the jam cools, it contracts slightly, creating a tight seal that extends its shelf life. Finally, the jars are grouped into sturdy boxes and sealed for distribution. These boxes are transported by truck to storage centers, where they must be kept under optimal conditions: a cool, clean, dry environment with good ventilation. This guarantees that the jam retains its flavor, texture, and quality until the moment it is enjoyed. And that is the full process behind the production of, well, tons of jam. What do you think of this process? Let me know in the comments if you enjoyed the video. See you next time.